here's the assignment for today. The first thing that I thought I'd have you all do is each take 2 of the bowls and count the duckweed, the fronds. Let me tell you, if there's the slightest little outcropping coming as a frond, I count it. And it'll continue to be in my count as time goes on, all right? Because you can imagine at the stopping point of this, they're going to be all different sizes, and what are you waiting for?
This morning the teachers are looking at bioassays, which are using plants and small organisms to look at the effects of contamination, for example. So we're using duckweed or Lemna minor and Daphnia, which is a water flea. And we have 4 different concentrations of arsenic, so 0, 10, 50, and 100 parts per billion. And we put the same number of Daphnia and the same number of duckweed in 2 different projects in the water, and then we're counting to see, this was a week ago, so we're counting to see the effects of the arsenic on the organisms. They have these picks, and they're using them to pull, the fronds can be super small on the duckweed, so they're using them to pull them around and count them. So we started off with 30 fronds of duckweed, so we're seeing how many more there are, and if that changes from the different concentrations of arsenic.
Oh yeah, now see, when I'm down at this level, I can see more underneath. Look at that.
This is harder with some of the little buds.
Like this right here. Mm-hmm. Is this 1, 2, and then 3, 4? Are those little ones coming?
I think so. That's how I was counting it.
Make sure that we're, look, yeah, the underside's very purple.
Right, where you can actually see the whole thing.
I think one of the things that would definitely come up in the classroom is clarifying what is a frond and what is not a frond. Because I mean, like looking
And a light,
here,
I think what would help me is a special kind of
like working under a light, like right
working
here
under a
is a
light.
good example. There's 1, 2, 3 fronds, but that 3rd frond is a tiny little bud.
I really want to do some of these bioassays with the kids, particularly the Daphnia ones, because I think the chance to interact with living organisms is super cool, especially for middle school kids. And just the conversations about the variability in the numbers we were getting and the human error aspect of it, I think will be really interesting to kids and important to talk about and dig deeper into.
I know, that's the thing, is this...
Oh, easier on the white.
Is it easier on that?
Yeah, it's down. It's on the post.
So could you get me set up under this microscope so I can show them how to do that?
My name is Jane White, and I work at Tremont Consolidated School over in Bass Harbor, Maine. Being in the laboratory at the MDI Biolab is really exciting for me because it brings me back to the days of when I was a student. And I think as teachers, sometimes we forget being in that role as a student, and it reminds you how difficult doing science can be, and following directions and counting and making sure that the methods you're using are unbiased, because you have many people with different ideas looking at things with different perceptions, so they might count differently. It's so fast, I can't count.
Can I look?
Yeah, maybe I'm crazy, but...
No, I'm sure not. Oh my God.
But to fit them all up, I would sort of say
Yeah, but that's fast.
I guess I'll go for it.
Okay.
You say go.
Okay. Thank you. Go.
Okay.
But I wish I did have a line.
So it won't be associated, right? It will.
Stop.
71.
Oh my word.
I know in my classroom sometimes it's you do something, do an experiment, okay, that's it. It worked or it didn't, and that's it. And you got to get them to think about why.
Let's suppose they count 5 Daphnia in their dish once. Each Daphnia gets counted once by one student. You could work with those data and the student could make sense of it and so forth. But at some point, you might want to ask students, how certain are you about whatever claim they're gonna make. It could be that we each counted one and we're all different people. It could be that, well, how are you gonna test that out? And then maybe students can think, oh, well, I'll count it 3 times, or I'll count it once and you count it once. Or maybe they'll think of a way to check that little conjecture that it was due to their counting. Students will almost automatically say, well, it's variable because we did it wrong, or, you know, how many times have you heard that? And I like to try to steer students away from that as an automatic explanation, because we've not paid enough attention to natural variability.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. All right. Tell me right. All right, ready, set,
we'll get us another dish to put the ones we've already counted.
Oh, good idea. So we're going for 15.
It always helps me to be put in the position of a student and to realize what I'm expecting of them. Can I even do it myself? So I found my lab partner and I discussing the fact that we were the last ones there and how irritated both of us get with the really slow people in the class that are not slow intelligent, but slow moving. And yet we hadn't goofed around. We'd done everything we're supposed to do, and we still ended up, it just took us longer to get it done. And so that's a lesson definitely to take back.
So it's really good to think about what is it we're observing and measuring, and then make a column for each of those things. So I think this is a great idea, because you're gonna have a date like halfway through, right? And then today's date, and you might have another date.
And another day. Yeah.
I'm really excited about this workshop because I'm excited about working with students around real data that they can collect themselves and visualizing that data so that it's meaningful, and also connecting it to current events like health and water issues in their state. So I think it's a great way to be able to take classroom data and make it relevant to their lives.